Okay. So originally I wanted to do the files and then go to smart pointers and stuff like that. So next week we can just start parallel processing. But I had like five appointments, and each one we're asking, how do we study? So we make sure we pass the subject. And I did a presentation once. Did I demo how to use ChatGPT to learn in class? I talked about it, but I didn't demo it, right? Yeah, so I'm going to demo it now, and I'm going to record that demo and show you exactly how it's done, because apparently nobody's doing it. And so I'm going to I have actually set up a fake account for myself, and I created a ChatGPT account for myself, and I'm going to bring it up, and I'm going to set it up for you, and then show you how it's done. Do a little demo so you can see. And many of you are more expert than me. If you are, let me know. When I say expert than me, you laugh. Getting the solution is not expert, okay? That means you're completely screwed up, okay? So I'm going to show you, do a demo. You'll see how it's done. It's going to take 20 minutes, half an hour, but I think it's worth it. And after this, if you actually follow this, I guarantee you pass with an A+. If you don't do this, not so sure. Take a look at the comments I gave you for your tests. You'll see what it is. Unfortunately, the level of, I don't know how many people actually passed. I think it's less than 10 in class. And what I saw was not that you didn't know OOP345. It was that you didn't know IPC144. Like, people couldn't write loops. People couldn't create variables. When they were writing integer a semicolon, there was a syntax error in it. And I gave you Notepad++ that helps you do that. And that was sad. Okay, so, and we have around 40 people in class, and take a look at the people sitting over here now. That explains everything. Okay, so if you have extra money, you want to flush it down the toilet, it's your choice. But if you really want to pass and learn and pass, not pass, the heck with passing. I hate that thing. So how can I pass? Ask, how can I learn? How can I pass? Who cares if you pass? Tomorrow you're going to get hired someplace, you think they're going to ask you, did you pass? No, they want to ask you to write some code. If you can do it, you're fine. If you can't, at least you need to learn how to ask ChatGPT to write you the proper code. Trust me. Like, you'll see. Anyways, I'm just going to show you either, if you know it, fine. And if you don't, then it's going to be good for you for entire study and things that you're going to do with AI. So you create an account with AI. So this is what you're going to have with AI, right? Now, I have heard, like, I've tried different things. I'm not advertising which one is better, but for some reason Grok did a better job than ChatGPT. But the problem with Grok was that it did not export files properly. In ChatGPT, you can export things in PDF if you want to. That's the next point that I have. Can you afford $100 to hire a tutor for next 2 months? No, sorry, less than that, $35 to hire a tutor, expert tutor with PhD, an expert talent of tutoring, to be with you 24/7 in next 2 months, so you can pass the subject and get a good mark and learn it properly. If you can, register. You can say upgrade for free. They give you the business account for 1 month, and business account is much more sophisticated than the one that is paid. And after that, you can cancel and get a $35. I think it's $30 US. I don't know how much is it monthly, but I think it's $30 US. So something like that. So you get that one, then it's not going to be slow anymore. Okay? And I'm going to tell you when it becomes slow. Yeah, it becomes slow if you continue a chat. I'll explain to you. So we'll go through all the detail to teach you actually how to use it. okay? Not as a plagiarism, not as a plagiarizer, a cheater, but as a person who wants to learn, okay? So this is important. Let's go through this. First, you create the account. The very first thing you do, you click on your name over here, and you go to Setting. In the second, you go to Personalization and Custom Instructions. Over there, I'm going to say, I am a student of CPA program in Seneca Polytechnic in Ontario, Canada, okay? And want to use you to help me learn my subjects, or my help me study and learn. If you haven't done this, the AI doesn't know if you're a 90-year-old grandma or you're a 7-year-old kid. Doesn't know how to talk to you. So this tells you what it is. And then in here, you can actually mention what's going on. You gotta say, I look at yourself in a mirror and see what type of a person you are. I am extremely quick learner. It takes me time you have to repeat something 3 times so I can get it. You gotta mention all those things in here. First, customize it so it knows who you are. That's number 1. You save. Then you close and you go to projects. Now in this project, you are going to explain what you're going to do. Is it, I don't know, geography you want to learn? You want to learn, I don't know, databases? What you want to do? So in here, I'm going to say learning C++, learning object-oriented programming using C++. Now, because I created already this thing using C++, because I'm going to say create a project, okay? Now, when I created this, it asked me, what do you want to use this thing for? I went over to education and study. So this account is set for education and study. Later on, we can change those settings, but it's going to ask you right off the bat. So set those things. We good? Down to this point. Next. You created the project. You go to the setting of the project, and you go add instructions. Now, I have written instructions, and I'm going to put this thing in your account. Let me bring it up in that notes. And I'm gonna name it. Give me a second. Let me go bring it. So I named it Learn How to Fish. .md, okay? Of that expression that says, don't give me fish, teach me how to fish, okay? So this is the file. I'm going to say over here, paste, and let me open it up. All right, did it open? Yeah, okay, so it's here. Now I'm going to. So the instructions are here. You just copy and paste it. But when you copy and paste, you make sure you copy and paste it as MD file. Just don't do this. Any instructions you write in MD format. Judging your README files in your repository, you couldn't write the bullet form to put your names on it. Please, go take a look at the form. It's much easier than HTML. 2 seconds it's going to take you. Okay? Literally half an hour you can learn what the format is. Learn the format of an MD file and go through it and you'll be just fine. So, and I'm just going to open it in Notepad and copy the text over here. And I'm going to paste it over here. So what does it say? Oh, let me take this out. This is, you don't need this. This is the title of the MD file, so we don't need that. I am learning programming, and I want you to help me understand and practice, not just give me solutions. While tutoring me, follow these rules. Explain the concept first, 1. 2, then ask me to write the code myself. 3, when I show you my code, review it, point out mistakes, misunderstandings, or logic issues, but do not give me the correct code. Let me fix my code on my own based on your feedback. We repeat this until my code works correctly. Only after my version works, show me a more efficient or professional version of the same solution for comparison and improvement. Important, do not give me answers directly. Teach me to think, debug, and solve problems on my own, and then add a URL to the subject. Or if you can put PDFs, you can add files to it. If you don't have, if the notes of the file of the subject are in PDF, just upload the PDF as files into the project. So the project's going to have that one. So I put the path for the advanced OOP, stds.ca, and that's the thing. So I'm going to say save, and that becomes the thing. So now it knows what I want to do. OK? So let's learn how actually I deal with this thing. So I'm going to open up the notes. Let me bring it over here. Where is it? 3, 4, 5. OK, so let's study. What do I do? Algorithms? So let's say I want to start algorithms, right? I'm going to get the copy of algorithms, OK? I'm going to say let's tutor me to learn the material covered here. OK? Then it's algorithms, right? But you have problem with containers. If that's the case, immediately write over there, knowing the fact that I do not understand containers properly. But again, doesn't matter. What you can do, I'll show you what happens. So in here, I'm going to say start. It's going to be a little slow because it's a free one. Oh, it's going to open and start. Oh, the other time it opened it, but now it doesn't open. Why it couldn't open? Anyways, if it can't open, download it, put it in files, and simply say this file. It doesn't matter. It doesn't make any difference. OK? It is guessing what's going on, but it goes through it. So it actually is going through it. Practice topic 1, find, and yada, yada. It says, let's start small, and then it starts telling you what to do. And give it a second. So as you see, it's giving you something. Now, if you don't understand it, simply you say, step 2, practice. Could you please explain a little more? It will explain it to you. Or if you did something like this and you see it talks about vectors and you don't understand, simply go up, edit the thing over here. Why didn't it get the thing? It's funny. Sometimes it can, sometimes it can't. Grok doesn't have that problem. Grok gets it immediately. But anyways, you can just edit this and ask over here, knowing the fact I don't know containers well. then it's going to regenerate everything knowing the fact you don't know containers. Or simply you saw over there some term that you didn't understand. So I'm trying to see if there is a terminology over here that anyway, so that's it. So now in here it's telling me to do what? It's telling me write a short C++, creates a vector with at least 6 numbers, asks the user to enter a number to search for, uses find to check it, uses count to print how, yada, yada, yada. Now in here I'm going to say I don't know how to create a vector with values. Help me. And then it continues. So you keep going like this, and take a look at the recording of the other class, because over there went much better than this. It went through all this stuff and found everything. Okay? You can try it with this, the free one. Try it with Grok. Which one is better? Whichever you see talks to you better and understands you better, use that platform. Or whatever platform you find out there and you know better than me. If you use it like this, I will guarantee you will pass the subject with an A+. If you do like this. If you don't, you can use the conventional ways that you learned. Some of you already did perfect. And if you're one of those, just ignore what I say, do whatever you were doing before. Yeah, so that's it. Any questions on this? Yes? The instructions? It's in the notes today. If you go to today's notes, it says learn how to fish.md. You open it up, it's going to be instructions. Let me change it. I'm going to say ChatGPT instructions. I'm going to make it GPT instructions. I'm going to call it GPT instructions. Give me a second. So I'm going to call it GPT instructions. Please don't blindly copy the entire thing. That thing is a document for you to read and understand. Okay, it's not. So when you open that, where is it? Yeah. Anyway, so let me close this one up. We good? We're okay. So this is I wrote it like this. You see GPT instructions.md. So you can go in there, and let me just copy it and do the same thing for the other class. If you look at NRA's class recording, it went pretty well over there. So you can actually see what is that. I'm going to say paste and remove this one. Okay. That's that. And now today's work. First off, let me actually add a couple of projects, a couple of things to our three. So we talked about files and we went through files and we wrote few things, and we kind of understood how binary reads and writes work. Now, looking at, let me just have this for a second. Just a second. Where is it? Okay. All right. So we have that. All right. Let's talk about writing into a file in a binary format. We already learned how we can actually read and write stuff into a file using the same style we use for C in and C out, which is essentially insertion and extraction. But what we can do is actually write everything into a file in a binary format. What does it mean? So when we are opening a file, when a file is open, we use OOP345 in this case, and I'm opening something called nums bin. And I'm saying iOS binary. By the way, iOS binary, add it. But on Linux, it doesn't make any difference. For Linux, everything's binary. It's for Windows that you have text and binary. On Linux, all files are binary. So iOS binary, write it. Over there, it's going to be ignored. It doesn't make any difference. But in here, you should do it. So you write iOS binary. You're essentially telling to your OOP345 that this is not text. I'm writing stuff in binary. Now I have a vector of 4 doubles in there. So what I do, I start from the beginning and go to the end of those doubles. And one by one, I use the method write of the OOP345. The write method writes, that's wrong, dumps series of characters into a file. Now those characters we consider as bytes. IPC 144, character is essentially a byte. It is not a character. Okay? So the only reason we show it as a character because the size fits at the ASCII code of a character. That's why they call it char. It's literally a byte. Everything can be broken down into bytes. Therefore, I'm going to say start from the address of V, which is essentially the address of the current element of the double in the vector. I'm going to say cast it to a constant character pointer. So the address of V, which is a double that is 8 bytes long, the address of the beginning of it will get converted to a constant character pointer. Now, looking at this, write thinks there is a character array over there. So how many character arrays I should copy and write into the file to cover the whole double? It's size of the double, right? So I'm going to say size of V, which in this case is 8. So it starts from the address of the beginning of those doubles, right? One by one, it's going to write them into the file. And then goes to the next one, writes that one, goes to the next one, writes that one. And it keeps doing that. And the result of that will be And the result of that will be, did it compile? Control 5. There we go. This is the outcome of it. Obviously no output. I'll come over here and you see nums bin. So this is what's going to get saved in a file. It's essentially 4 8 bytes. That is what? 32 bytes. So you literally have 32 bytes of binary stuff written over there. These 32 have the exact same bit pattern of those 4 doubles. Be good with this? Okay, so now that it's written over there, how can we read those things? I'll do the exact same thing I have done when I was writing it, but I'm going to go opposite, which is reading. So I'm going to create an ifstream file, nums bin, the one that I just created, as binary. I'm going to create one single double, no vectors in here, because I just want to read and print them. So I'm going to say while file is not in a fail mode, which means it's still valid, read, reinterpret cast the address of the beginning of the variable that I have into a character pointer, not constant character pointer, a character pointer, because I want to write into it. How many bytes? 8. So it literally reconstructs the values of the double from the bit pattern in a file, which I just wrote. Therefore, it's going to reconstruct the double with the very first double that we have. And the outcome is going to be sorry, sitting and standing is difficult. Just going to bring it up so I can. Okay, so what it's going to be will be this. Opens the file, double has garbage in it. Now it goes over there, read 8 bytes from the file, and now double has actually a value in it, and it prints it out. Next, 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 and now it is still valid. It's the last one. Tries to read it, but it fails. Because it's in a fail state, I can actually write something like this over here. Else come on, and L, okay? And I can put an end L at the beginning too. Recompile, let's hopefully it works. And now it fails and says end of file. And because that thing doesn't work anymore, it comes out and we're done. Okay? So everything is gotten back. So why we did this? Why not just write as text? First of all, look at the size. If the double values that you have are not big, like you can have double values that are like 15 characters long, it's going to save space. But that's not the case. Usually binary files don't save space, they waste it. But the thing is that now every single double is exactly 8 bytes. It cannot be 7 bytes. It cannot be 9. It is every single double is 8 bytes. What good does it do? There is a beautiful thing in ifstream and OOP345 called seek. Okay? So in ifstream, because it's reading, you put seek G. G for getting. I'm getting stuff. So it's seek G. In OF stream, where you are writing, it's seek P. So essentially, it's P. What seek does, it tells at which byte of the file next operation should happen. One more time. Seek says at which byte in the file next operation is going to happen. So if you are at IF stream and reading, if you say seek G0, it means the next read is going to happen at the beginning of the file. If you say seek G8, it means next read will happen on the 8th byte of the file. So you literally tell where the next operation is going to happen. There is another function called tell G and tell P. Tell G tells you at which location in a file the next operation is going to happen. It's going to tell you right now. So we can play a trick. For example, I can do this. Oh, seek G has two all seek operations. So in here I'm going to say seek. I'm going to do that. Okay? So can be either G or P. Okay? There are two overloads. One is stream position value, which is essentially tells you where to go. Where is the next one from the beginning? Whatever value you put, where is the position you want me to be at? And the other one, seek whatever is stream offset. And the second one is from where. And stream offset is again a value. So this value is positive. From the beginning of the file, value is positive. From the beginning of the file, you cannot go backwards. It's stupid. You cannot say position -1. It doesn't make sense. But for stream offset, value is either positive or negative. Positive or negative, both of them. And from where is iOS beginning, iOS end, or iOS current. So you can say from current position, go 2 bytes back. From current position, go 50 bytes forward. You can say from the beginning of the file, go 50 characters forward, which is essentially right, like the seek that you're doing over there. Or you can say from end, come 50 characters back. So it's just logical. When you are saying iOS beginning, don't put negative values. That's stupid. You're at the beginning. You can't go back. Or when you're at the end, don't put positive values. You can't go further at the end. You have to come back, right? It just makes sense. Now, take a look at the code. So first, I'm going to say seek G0 iOS end. What does it mean? It means the next action should happen at the end of the file 0 bytes further, which means at the end of the file. Now, tell G will essentially be size of the file. So I can actually say in here, I can actually say cout file size is tell G, whatever bytes, or I can say over here bytes. And in here, what did I do? I said go to the end and divide it by the size of double. What does it mean? you can actually see how many doubles you have in a file, number of records in the file. So you can go to the end, see what is the size, divide it by the size of the record, and you have the number of records. So in here I can say I don't know why I'm always surprised, but hey. Okay, so let's go through it one by one, and then I'm going to explain as we are walking through it. So, okay, I'm running the wrong thing. I changed the wrong file. Give me a second. Control A, copy. Just a second. Sorry. Just a second. Save. Close that one. Okay, stop, and let's do it one more time. So, what happened? Let me take this away. What is this? Okay. All right. So let's go through it one more time. All right. So I'm opening the file. I'm having a double value over there. And then what I'm going to do is, I don't know why everything, Control K in, sorry, edit, document. There we go, much better. Okay, so let's go one more time. Yeah, so I seek to the end of the file. Now I'm going to say the file is 32 bytes. Okay? Now, I'm going to divide that 32 by the size of the double, and it's going to tell me exactly 4 doubles in the file. Now, I'm going to seek from the beginning to the size of 2 bytes, two doubles, which means it's going to stand at the third one. So when I read, I am reading the third value. Remember, 10, 11, 12? This is the third one. Now, I'm going to say go back to the beginning and read. Now it's going to be the first one, that is 10. Now I'm going to say go to the end and come back minus size of a double. You see I'm casting it to a string offset. If I wrote this program 10 years ago, I didn't need to do all these casts because at the time it wasn't that type safe. Now it is. You can't just say minus size of. So that's what happens. Okay? So I have to actually cast it to the size of, and then I come back. Now it's going to go right to the last one and shows me the last one. So as you see, I read the third one, then the first one, then the last one. And the speed of reading is as if you are reading the first 3, because you jump to the location that you want right away. You don't have to do a sequential read. We good? We okay? All right. So stop. They called it random access. Why? Because you can access any part of the file as you want. It doesn't have to be a specific place. Now, do you hear something whistling, or it's just in my brain. Yeah, so I'm not nuts, so something is whistling. What is that?
I think it's the heater.
Like, so now let me bring it back up and then start the new topic. So now let's add a new project to this. Add existing project. Open. And set a startup project. Oops. So I'm going to add a CPP file to this. This code is old. It's when the school was called STDS. So
What's it called now?
CPA, I think. SCPA, School of Computer Programming and Analysis. So what do I want? I want prg.cpp. Do I have a prg.cpp in there? Add. Oh, wait a minute. I think we have it. It's a dot. So we add it. Add existing item. So let's take a look at this. Look at this thing. I have an employee.txt file in here. Remember that thingy that we had with the Simpsons characters as employees? So these are all the employees that I have with employee number and their salary. And they're all up there, okay? Now, look at this thing. Now, what I'm doing, do I need to go? Let me go through the employee one more time.
I have a question.
Yes.
Why do you name the employee like the variable in the Pascal case?
Which one? Which one you're
Like the first letter of the employee variable. Why is it not lowercase e?
This one?
Yeah, I'm just wondering.
I'm a bad person. I'm not supposed to do that. Yeah, variables are supposed to be lowercase. But when you put a single one, I just want to show it's an object. So, I'm doing it that way. But it's supposed to be lowercase. You're right. You're absolutely right. All right. So look at the employee. So what employee has? Very simple. It has a constructor that receives a salary employee and the yada, yada, yada. And it has a less than operator overloaded so we can compare two employees for whatever reason, either their names, employee number, or whatever. And you can print it and you can read it, okay? And the insertion and extraction is overloaded over there. So when we look at the employee, we know that that's the employee. This is me doing string copy because I didn't want to include string copy, and this is me doing string compare. So line 15 and 16 is a string compare, 10 and 11 is string copy. So essentially, I'm reading the string, setting it up, and this one I'm comparing. So the comparison compares two employees with their name. Print is printing it out, and read is literally reading that line by line from the text. We good? Are we okay with this? You want to? Any question about it? So it's literally reading this. Where is it? Where is it? Where is it? So I'm literally saying get line up to the comma, then ignore the comma, and then get the employee number, get the salary, and yada yada. So I'm going through all these things right now. And it's essentially reading the employees from there one by one. It's as simple as that. Okay? So what else I need to do over here? Okay, so what I'm doing in here is essentially this. Take a look. First, I'm opening the employee the employee.txt. Obviously, I'm reading it one by one, as you see. So it's reading all the employees. Then I'm going to go to the cursor. So all the employees are read now and printed. Okay, so it reads the employees and print them. Now I want to show the 10th record. So I've written a function that shows the 10th record. Now it shows the 5th record, 13th record, and the 100th record. And it says end of file was reached. So we're good. We understand what show record does, right? It looks like I'm doing random access to the file, right? Because I'm showing the 10th, then I'm going back to 5th, then I'm going to 13. But take a look at the file. The size of the file, because it's text, it's all variable. I don't know what is the width of the record. I cannot jump to the 10th one. It's absolutely impossible. So how do I fake it? This is how I fake it. I'm saying, I'm going to show a record. Give me the row number and the file you want me to read from. Very first thing I'm going to do, I'm going to make sure if it's failed, I'm going to clear it. Then I'm going to go to the beginning of the file, keep reading to the number of rows, one before row, and then read. So essentially, if you want the 10th one, I'm going to read 10 times, and the last one that I read is the 10th one, right? So if I want to read the 15th, essentially I'm reading 14 and throwing it to garbage, then I get the 15th one. So when you say 10, I read from 0 to 10. Then I show you the 10. When you say 5, I go back again, read everything to 5, show 5, and I keep doing that. Now imagine if there were like 30 million files in there, 30 million records in there. You know how long would it have taken to show you the 5th one, then go to the 100,000, then you come back? It would take a long time. This is sequential reading. It's faking random access. We don't want to do this. We good? Right? Okay. So what is the proper way of doing it? The very first thing I'm going to do is not that one, not that one. Oh, I don't have it here. Interesting. Anyways, I'll do it. First of all, I'm not going to create the file. I'm not going to create the file using, let me see, what is it using? It's using the employee. Give me a second. So we don't have this here. Give me a second. I'm going to bring the other one. Let me pause the recording for a second. Prepare the other one. And resume. Okay, so the very first thing that I'm going to do over here is this. Instead of creating the file as text, what I'm going to do, I'm going to have all the records of the employees written exactly the way we mentioned for the doubles. But the difference is that instead of going through the vectors of doubles, I'm going through the vectors of employee. So essentially, I'm going to say cast the address of the beginning of the employee and to the size of the employee, write it into a file. We okay down to this point? It's exactly like the double one. The difference over here is that the employee that we have over here, take a look at it. You see this? The employee that we have over here, this will be the size of the employee. When you are writing a binary composite type into a file, the methods of the class won't occupy space. You know what methods of the class are? Like somebody's skills. Like if I know how to dance, it's not going to add to my weight. I just know how to do it. Methods don't add to the size of the thing, a class. A class's size is only its attributes. Therefore, when it goes to the beginning of the thing, however that salary, employee, and name are shaped, it's going to actually be that size that's going to be get saved into a file. So therefore, when I run this program, a file is created like this. Now, when you look at the file, you could actually find out the names of the classes in the binary file. But the rest of the information that are integers and doubles are all cryptic. It's not cryptic, it's just in binary. So you can't see anything. So doing something like that, the advantage that it gives you is that now the size of the employees are equal. One is not bigger than the other or small or whatever. You can literally, doing this, you can actually access every single employee like we did with the other one. You can jump to the third one. So literally go get the code that I had for doubles, take it, put it over here, include the employee, and instead of a double, put an employee. You're going to read the whole thing. So you can actually go to the specific employee and read it if you want to. It's as simple as that. So essentially, so this is creation of that. So let me just remove. So this is what we had for the seek that we had over here, right? So I'm just going to copy this. Copy this. So I could literally copy this and include IO stream. We need that. Include F stream. We need that. What else we need in here? Using namespace std. Anyways, if we need anything else, we'll know. So the name of the file was, I don't want this. The name of the file was bEmployee bin, right? So we put it over here. Instead of double, over here I'm going to have I need to include employee. And bEmployee.h is not in any. Okay, good for me. It's not in any type of. It's not in any type of namespace. So I don't need to have any namespace over there. So in here, I'm going to have B employee. I'm going to have employee. V, I'm not going to change anything. I'm gonna actually do the exact same thing. I see what is the size. In here, it's going to be size of employee. Or I can put size of V, same, no difference. And in here, it's got to be size of V. Reinterpret cast to that, yada, yada, yada. That's correct. I just want to see if there is anything over here that needs to be changed. This is size of V again. Actually, it's a good candidate to write a template for it, to write a template to do anything, seek for any type of thing. So now, if I go through this, it opens employee.bin, has one employee, goes to the beginning, tells you what is the size, tells you what is the number of employees in there, then goes to the second one, gets it and prints it out because it's overloaded, and so on and so forth. So it's going to work exactly like the other one. I don't know if it's going to run or it's going to have syntax problems, but we'll find out. And L. Okay, so let's run it. Bring it to the left. Okay, so now I'm going to have employee.bin open. It goes to the end. Now the size is 1.2, 1002, whatever bytes that it is. I have total of 19 employees in a file. I wrote 19 employees. I seek to the second one, reinterpret it and read it and print it. The second employee comes out. As you see, it works exactly like the double with absolutely no difference. Got it? Down to this point? Now, let's make it even more interesting, and then we're going to go for a break. Okay? So, take a look at this. We understood what iterators are and algorithms are and all the good stuff, right? I'm going to show you a code and show you exactly how we can use this, we can do reading using iterators. Let me see, what do we have? Is it this one? Yeah, take a look. So what I'm doing in here, I'm saying open ifstream as binary. Then I'm going to say create an istream iterator. What is an iterator in a vector? Iterates over the members of the vector, right? So when the first one is pointing to a vector, it points to the first element of the vector. This iterator points to the first element in the file. Exactly. You don't care. That's the good point about it. I'm going to say create an istream iterator for the type employee. So it knows the size and everything, and it sets that iterator for the type employee. And I'm going to say initialize it with the file I opened. So this iterator is going to point to the beginning of the file. Then I'm going to say create another iterator. I'm going to call it end of stream and make it a blank one, which means the end. Remember I told you the last one is one after last. There is nothing in it. That's what I'm doing. It means an empty one. Then I'm going to say vector employee. How do we initialize a vector? We can actually copy a vector out of another vector, putting the iterator of the beginning of that vector to the end. It literally makes a copy of one vector to another. It is doing the same thing, making a copy of the vector of the file into the vector of the memory. So without a single read, automatically your vector will be filled with all the data in the file. Then I'm going to say, go from the beginning, one by one, show them. Not only that, I am passing that vector into a sort, employee begin and employee end. Because I overloaded the less than operator, it will sort it automatically. and it's going to print it. So in 20 lines of code, and what I'm going to ask you, and I asked the other class to, go home, change these two for loops to a for each STL. So these become one line with a, what should we call it, with a lambda. Try it. That's going to be your question for the quiz. Okay? Make sure you can do it. Okay? So now, if I actually run this, to convert a regular loop to an STL. Okay? So it's reading it. It's set. So now everything is set. I have a file open. I have an iterator pointing to the beginning of the file. I have an iterator pointing to nothing, which means the end of the file. Then I'm going to say fill the vector from the beginning to the end. That fills the vector. Now, one by one, it's going to show all the values in the file. Even better, now I'm going to go to sort. I'm going to, let's say, run the sort algorithm from the beginning to the end and print it again. And now everything is sorted in here. So yeah, so that's that about the files. So now you know everything about the files, and you come back. I'm going to tell you one more thing about the file. So this type of binary write was for type of composite type that has everything within. As you saw, it had the name in there as a constant size. This class was not with resources. It was an empty class. It was a class holding everything inside. Okay? That's why everything happened so nicely and easily. For the next one, it's going to be after the break. Okay? How much time do we have? Yeah. So 5 minutes break. I'm going to make things ready, and then you can come back. So that employee was easy because it didn't have any resources out of this scope. The employee that we have over here, its name is dynamic. Just imagine, when you write this thing in a file, what will the system get the address for? It gets the address of a double, an int, and a character pointer. So what happens, it's going to dump all that thing into the file. So essentially, if today your name, dynamic name, is sitting a certain address in your memory, it's going to remember that. And then you save the file. 2 days later, you open it. It opens the file and loads back the address the name was in 2 days ago. It's not going to be there. It's all going to crash and go to hell. So nothing's going to happen. So for this, we have to kind of use the same strategy we did for copy construction, which means we need to do a deep saving and shallow saving. We had deep copy and shallow copy. Deep copy was to copy the dynamic memory and save the new address. Shallow copy was to save just the variables inside. In here, shallow saving is just saving the pattern inside the file, no problem, and also save the location of the name. So let's see how we are going to do it. To fix this problem, this is what we have. To fix this problem, this is what we have as a Is somebody singing? Anyways, so this is the file, the thing that I want to save. Okay? And this has some name or whatever outside of its scope. Okay? So when I want to save it, what I need to do, I need to have one file for the composite type, and I need to have another file for the dynamic one. So what do? When I'm saving first I'm going to save this over here. So it's going to save that. Then I am going to check to see what is the location of the current place that I'm writing into a file. Currently, I'm at the beginning of the file, right? So I'm going to create a small record over here, writing the location of the file over there. Then I am going to write the name. And after that, I'm going to save what was the length of the name. For the second record, I'm going to write the next name over here. Then I'm going to write what is the position, current position, and write the name over there. Then I'm going to write what is, oh my goodness, with a mouse it's very difficult. There you go. Then I'm going to write what is the length of the second one. So although I am writing 3 things in my data file, in my constant length data file, but the length of the records are always identical. Why? Because this one is an employee, integer, integer, employee, integer, integer. So the sizes are always the same. And when I want to read the information, what do? I just read the employee and put it in employee. Then I'm going to check to see where the name is. I'm going to keep it. Then I'm going to see what is the length. For that, I'm going to do a dynamic memory. Then I'm going to read the information into dynamic memory. And I reconstruct my reading. All this thing is done right in here. And I want you to look at it when you have a chance. Take a look at my write. I'm going to say I received 2 files for my write, not 1. So this is completely different. Because it has dynamic data, I need to hold the class, and I need to hold the class as data. So I'm going to say, tell me what is the current location on the dynamic file, the write one. So in here, I'm checking where am I writing at the moment. I keep it over there. So I need to do that. And I need to have the length. So first, I'm going to delete the name. I don't have the name. Whatever record that I have, I want to write into it, right? If there is a name, I'm going to delete it. Make sure, because it's reading, you have to delete the thing. Then I'm going to say read into me to the size of the employee. So essentially, the whole employee will be read into the employee. Then I'm going to say read to the size of the name location, the location of the file. So where the file is, where the information is, so it's going to read this record. So it's going to tell us where exactly the name is in the other file. Then I'm going to say read the length of the name. So it's going to get the length of the name from the second position. When those 3 are read, then I'm going to say if everything is good, now create dynamic memory to the length of the name. Then seek to the location of the name. Go right before the name. And now read the name. So it reads exactly that much and make the last one 0. So essentially, I put a, a null termination at the end too. And now I read the whole thing. Okay? For writing, it's easier. All I need to do is to see, for when I want to actually write into it, all I need to do is to see exactly where is the location, what is my name, what is my length. I'm going to write the name in it to that size so I know exactly where it's going to go. I have the location over here, then I'm going to write the class, then I'm going to write the location, then I'm going to write the name, size, and I'm done. Okay? So executing this will give me these 2 files. Employee bin, that is all binary stuff. There is nothing in it. There is no name over there to read. But when you look at name.bin, it's all the names that you have in there, compact back to back. It starts over here, so it doesn't need to care where the other one is, and because it knows Homer starts from 0 and it's the length, it just goes right before Ned Flanders. And it knows exactly where Ned Flanders begin and where it ends at the end, right before Wayland Smithers. So it knows exactly what it is because I saved everything. And that's essentially what we call an index file and a data. You took databases, right? You know how to create an index record and data? You know, when you create a table, you don't create tables yet? SQL? You do. When you create a primary key for it. The primary key is the one that you can do fast search on it, right? This one is your primary key. And this one is where your data is. Because this one you can literally jump to the thing and find out where the location of data is. That's why in databases primary keys are fast, because they use certain strategy to, yeah, anyways. So it's kind of like this. So this is essentially how you keep binary data with its files. But of course, when you have SQL, you don't do this thing. So you just save everything and reconstruct it and come back. You just save it to the database, right? But this is something that you needed to know. And good news is that this is not going to be in a test or anything. This is outside of the scope of the class, but I believe my students need to know this if you want to actually do something proper. Now you can format your brains and forget what I told you after the break. Okay, so I'm not, the other one that doesn't have resources, you're going to have that. That's binary read and write of a composite class without resources. You will have that one. This one, you won't. But if I were you, I would go through it and completely understand what it does. And if you look at here, yeah. So yeah, that's it. Anyways, questions? Suggestions? Objections? All right. Next day you are coming in, we're going to talk about smart pointers, okay? Which means have a coffee before the class, sleep well at night. When you come, we're going to talk about some nice stuff. And it is not a long session, but it's a very pointery session. So go brush up on your pointers. Go on ChatGPT and say, teach me pointers, okay? And give the link for OOP345 or something, or some pointer thingy. Or just say, I need to know what raw pointers are. Raw pointers. I'm not going to teach that. I talked about it at the beginning of the class. So raw pointers, go read raw pointers section. I'm just going to teach this the smart one and the next. I think it's parallel processing. So those are the things we're going to go through. Please. Pardon me? Yes, you will have quiz next week. Quiz. You're going to have quiz next week. I'll tell you again what the questions are going to be as usual. Okay? Questions? Suggestions? Objections? All right. Have a good day.